All right, class. Sorry. You know how the little document camera acts up, so I have a hard time. I don't know why that happens. So I'm trying to record. I have a hard time trying to set up my camera here on the side with this document camera. So I'm not sure what the issue is. So sorry about that. But anyhow, I'm trying to record myself so I can do the lesson 9.1. And let me see, it looks fuzzy. Let me see if I can clean the document camera. All right, that's better. Okay. So I'm going to go over 9.1, which is called solving linear equations of the form x plus b equals c, and also of the form ax equals c. So this is going to start on page 88 of your workbook, and this is going to cover test 2 material. So it covers 9.1, 9.2, 9.3, 9.4, 9.5. We actually have permission to all the elementary algebra instructors have permission to skip 9.6. And I believe that has to do with rate of motion problems like trains and cars overtaking each other. So they allow us permission to skip that section. And then we do 9.7. Okay. So test 2 will cover these 6 sections. Okay. And the first thing we'll go over in our workbook is the steps. So it talks about the linear equation in X. If A, B, and C are constants and A should not be equal to 0, then a linear equation in X is going to be an equation that can be written in this form, AX plus B equals C. So linear means that the leading exponent on the variable term is to the first power. So this ax plus c, there's actually like a little imaginary 1 there that the book will not bother writing ones, but you know that is larger ax to the first power plus b equals c. And if they say that's a generic linear form, okay? And so if the next chapter, test 3, is graphing, we will be graphing lines. Quadratic is x squared power. So if you have a quadratic equation, that is of the form, like for example, x squared, you've got the x squared, and that looks either like a parabola, usually. So we won't be graphing those. We won't be solving quadratics. And if you have to take intermediate algebra, you will do that. And if you have to take the STEM courses, you will be doing that. But for our elementary algebra, we're just working with x to the first power, and we'll just be graphing lines for the next test 3. Okay. The addition principle of equality. It says if the same algebraic expression is added to both sides of an equation, the new equation has the same solution as the original equation. So we will be doing that. We'll be using the addition and subtraction properties. We'll be adding to both sides and subtracting to both sides terms. But you do one side, you do the other side. So we'll be using the addition principle of equality, and it could be adding or subtracting terms. Symbolically, if A, B, and C are algebraic expressions, then the equations A equals B and A plus C equals B plus C. So it's just like if what they're doing is if they're adding, if you have A equals B, which you do to one side, you add C, then you do the other side, you'd add C on both sides is what they're saying. So yeah, then you'd have A plus C equals B plus C. That's kind of what they're doing there. They have the same solutions. Okay. Procedure for solving linear equations that simplify the form x plus b equals c. So these steps are important for solving equation. You want to combine any like terms on the left side of the equation, any like terms on the right side of the equation. Really, there's like there is really like a step 0 here, which is to do any distributive property first. If you have distributive property, you should do that. And then after you do your distributive property, then you should look to see if you can combine like terms on the left side of the equation and then combine like terms on the right side of the equation. And then you want to use that addition principal property of equality, where you're usually either adding or subtracting this same term to both sides of the equation. So they say that you're adding the opposite of the constant b to both sides of the equation. So you're adding the opposite. The objective is to isolate the variable, get the variable by itself on one side of the equation, either the left side or the right side. So they don't mind when you solve it. You're either going to have x equals something, x equals 5, or you're going to have 5 equals x. So they don't mind if it's on the left or the right, but they just want it isolated, and you want to solve for 1x, not 2x, 3x, or negative 1x. You want not negative 1x, you just want a positive. So this is a positive right here. You want positive 1x, x equals something. And then they do encourage you to check your answer by plugging it in. You would, once you get an answer, you would substitute your answer into the original equation. And remember, you want to get a true statement. If you get a true statement, the left side equals the right side, it's true, then you feel comfortable that you did your math right. But if you get a false statement, that means that's not a solution to the equation. So maybe you made an algebra mistake somewhere, or maybe you made a mistake in your check. Okay, but if your answer is a solution to the equation, you should get a true statement. The left side equals the right side after you plug that in. Okay. So you remember, you want to spend 50 minutes and learn, and this is part of the ebook. So you'll go through the watch and work questions that they have for you, and the videos that will help you pass the time away. Okay. And then down here at the bottom, they have there's a multiplication and division principle. So first we always try to do the addition and subtraction properties, but then after you've exhausted that, then you try to multiply or divide. So it says that if both sides of the equation are multiplied by, or they could be divided by the same non-zero constant, the new equation has the same solutions as the original equation. So symbolically, if A and B are algebraic expressions and C is any non-zero constant, then the equations A equals B is equal to A times C, which is equal to B times C. And of course, C should not be 0, because anything times 0 is 0. So what they're doing is they're multiplying both sides by C. The left side and the right side is being multiplied by C. And they're just not going to let C be 0. Okay. So usually you multiply both sides by the term. Is usually what I'll use that for is if I have fractions. So usually when we have fractional, we can say fraction, fractional fraction coefficients. That means that the number in front of the coefficient is a fraction. We have fractional coefficients. Then that's usually when we multiply both sides of the equation by both sides of the equation by its reciprocal. when you have a fractional coefficient, you multiply both sides by its reciprocal. And they're just saying generic, they're gonna multiply both sides by C. But that we're saying it's reciprocal. And here's the division principle. A divided by C equals B divided by C. So then looks like they're dividing both sides by C. Okay. So usually when we divide both sides by coefficient and use the division principle, that's because when we have either an integer or even a decimal coefficient. Then we can divide both sides of the equation by the coefficient itself. So we have an integer or decimal coefficient, then we divide both sides of the equation by the coefficient itself. Okay. So we'll see some problems where we get to do that. Okay. So if you need to pause the video, you can pause the video to write that down. Okay, so let's look at some of your problems. And we'll start with the ones in your workbook. Let's see. Oh, I didn't realize there's more steps here. Let's see. They look similar. I guess they're summarizing the steps that you would want to combine like terms on both sides of the equation. And of course, there's like the step 0, which would be to do any distributive property first, if you have that. That should go first. And then combine like terms on either side of the equation. And then you're either going to be applying the multiplication principle or the division principle. So you're going to multiply both sides by the reciprocal, or you're going to divide both sides by the coefficient or by the decimal. And it says multiply both sides of the equation by the reciprocal of the coefficient of the variable, or divide both sides by the coefficient itself. Okay. The coefficient of the variable will then become, a positive one, 1x or 1a or 1c equals something. And then they recommend that you check your answer. You would substitute your answer for the variable in the original equation, and you want to obtain a true statement. Obtain a true statement. If you get true, then feel comfortable that it is a solution. So let's see. There's some questions I can go over before I do 5 and 6. I can go over these true or false. It says here that when an algebraic expression is added to both sides of an equation, the new equation has the same solution as the original equation. Okay, so that would be true. The process of finding the solution set to an equation is called simplifying the equation. Yeah, and they say that's false, that it's not because of this word. It's not simplifying. It's called solving the equation. A linear equation in X is also called a first degree equation in X. So yeah, that's true. Linear means first degree. Remember I said that you have that little one on there next to the first power. And equations with the same solutions are said to be equivalent equations. Okay, yeah, you could say that. Would they have the same solutions? Okay, equivalent equations. Okay, that's true. Okay, let's look at this would help you like if you were going to do a check. This is kind of help you what you would do if you have a check. So if you had the equation and you solved it, and let's say you got x equals 1, and then you wanted to do a check to see that was right, you would just go back and you would just sub, which is short for substitute. So everywhere you have an x, which is like right here, you would substitute it with 1. So now you have 1 take away 2, and then you have a question mark. Does that equal -3? Okay. And this is a sign rule. You have 1, you cannot give away 2, you don't have 1. That's a sign rule. So really they would want you to add the opposite. So change that subtraction into a plus sign and then take the opposite of that number, which would be of 2, which would be -2. So then this would be 1 plus -2. So you've rewritten that. And then you're still trying to find out, well, does that equal -3? So it turns out that it doesn't. 1 plus -2, that's rule number 2 in your sign rules. You're adding 2 numbers with different signs. So you really need to subtract 2, take away 1, which is just 1, but it's going to be, you're going to go with, they're both competing for signs. Go with the sign that has the most distance from 0. This one, 2, has a larger absolute value, distance from 0. And so that sign happens to be, see, negative. So that means you're going to have your result to be -1. And the question is, does that equal -3? And it doesn't. It doesn't. That's false. -1 doesn't equal -3. It's false. So what that means is that the solution x equals 1 is not a solution. And excuse me, it's not a solution to that equation, x minus 2 equals -3. Right, so let's look at the next one. And again, this is the bottom of page 90 in your big math 410 workbook, okay? 410 workbook. So -10 plus x is equal to -14, given that x equals -4. Okay, so you want to substitute everywhere you have a x, which is right here. You want to put in -4. So you have -10 plus, and then you're substituting, a -4. And the question is, will this result equal -14? That's what you're trying to find out. Okay, this is an example of rule number 1. You're adding 2 negative numbers, -10 plus a -14. So all you need to do is just add them up, add and keep the sign. So -10 plus -4 is a -14. And now you know that the left side does equal the right side. You know it's going to be true. T for true. And so that means that this is true. So this means that your solution x equals -4 is a solution. To what? It's a solution to what? To the equation -10 plus x equals -14. Okay. Right. Okay, so you can pause that if you need to. And I'm gonna go to the next page at the top of page 91. Yeah. Yeah, so these were like, these are kind of like a check. If you were to solve the equation and then you wanted to check your answer, like they say these are your answers, you to do a check, you would plug them back into the original equation and you want to see the left side equals the right side. And if it does, like this here, then it's a solution. If it doesn't, like over here, it was false, then it's not a solution to that equation that you were testing. Okay, so let's teach you how to solve these equations. So you can show your work either horizontally, and I believe Hawk's Learning will show you horizontally, and I just show your work vertically stacked up. And so it says solve each equation, and we're on page 91. So if I wanted to solve number 7 for x, I would need to isolate x and get x by itself. And you see right now, the x, well, x is surrounded by that -6. -6 is in the kind of like in the way of x from isolating it. That's the one you want to move. But the only way to move that -6 is you want to use that form of the addition principle. And so I say to use the addition principle because the opposite of a -6 is a +6. But what you do to one side of the equation, use it, you have to use it on the other side of the equation. And then these -6 and 6, those actually divide out, they cancel out. And then you're left with just this side, 1 and 6, which is equal to 7. So here you have, because these canceled out, you have x only. And then you added 1 and 6, you have x equals 7. Okay. Okay, and let's try number 8 next. Try number 8. So I would advise you to pause the video, pause it, and then restart it when you're done. And then we'll check the work. Okay, and so now I'm assuming that you paused the video and you worked it out, and then you got, did you get x equals -19? I believe you should have gotten x equals -19. Oh, excuse me. I'm sorry. I'm sorry. Okay, so if you add 10 to both sides, plus 10, you get x equals 19, x equals 19. X equals 19 if you add 10 to both sides. What I did is I actually edited the problem. Sorry to tell you that. I actually edited the problem, and I actually made this 9 -9 so that I could just practice some sign number rules, because over here on number 7, I got 1 and 6 is 7. I didn't use any sign rules. I didn't need any. So on purpose, I made that a sign number so we could practice that. And you still want to isolate x and get it by itself. So you want to move the -10. The opposite of a -10 is a +10. And these fall out. So you have x equals. And now you have -9 plus 10. And that is a rule number 2. You're adding 2 numbers with different signs. So you're going to need to subtract 10, take away 9, which is 1. And the 10 has the larger absolute value. Remember, you're competing, they have different signs. So that's why you have to subtract and you have to decide which sign to keep. And the one that's more distance from 0 is 10 units, has more distance than that has 9 units when you take the absolute value. So this is going to be positive, and it's going to be a positive 1. Let's see. Yeah, -9 plus 10. Yeah, is a positive 1. Okay. And then let me edit that again. Let me make another problem out of that 8. Let me come back up here. And let's say I had x plus 10 equals -9. I want to use, because number 7 didn't use any rule, sign rules. Number 8 used rule 2. Now I want to show you using rule 1 here. So if we rewrite this again, and we do like this edit, and we work x plus 10 equals -9, we want to solve for x. We want to isolate x here by itself. So the opposite of a plus 10 is a take away 10. You do that on both sides. And then these fall out because they're additive. Those are called additive inverses. Remember, number plus its opposite zeros out. Remember that? A number plus its opposite zeros out. So those fall out. X equals, and now you have a -10 and then -9 and the -10. So I'm going to put a little plus sign here, a little, as you can always, like, you should be safe by putting a little plus sign there in between those two. But it's like you're combining, you're adding a -9 and a -10, -9 plus -10, and add those. And that would be a rule number 1. You're adding 2 negative numbers. So remember, a negative plus a negative is a negative. And that gives you a -19. So that gets to practice rule number 1. Okay. All right. Okay. So I'm also going to say that we were using, on this example, I'm going to say we're using the subtraction principle. We were using the subtraction, principle. Subtraction principle. Using the subtraction principle, okay? Because you see how I subtracted both sides? So I'm saying that's the subtraction principle. Here, see how I added both to both sides? That's the addition principle. And here, see how I did plus 10, plus 10? That was also the addition principle on that. Okay. All right. Okay, now there's, besides the subtraction and addition principle, you heard from our other pages, we're reading out loud the steps. You know that there's a division principle and a multiplication principle also. So that we're going to show you one of each when we look at 9 and 10. Look at 9 and 10. 9 is 51 equals 17y. That's 51 equals 17 times y. So in math, we undo times, which is multiplication, by division. We undo multiplication by division. Okay, so I'm going to divide both sides, okay, by 17. Okay, so what we're going to do is we're going to divide by the coefficient itself, which is 17. Okay. And notice how I didn't say divide by the opposite. Notice how I didn't divide by negative 17. And don't do this. Don't do this. That's wrong. I didn't say divide by the whole term, the coefficient and the variable. Don't do that. That's not correct algebraically either, because then the y's, see, then the y's, this y cancels out. See, you don't want that to happen. You want to solve for y and you lose your y on that side. So don't do that. So just divide by 17, the coefficient itself. And 17 is called the coefficient. 51 is called something also. It's called 51 is called the constant. But you don't want to divide by the constant. You want to divide by the coefficient, which is divide by the coefficient. So 17, which is the number next to the variable. See that 17 times y is right next to that. Okay, so then 17 goes into 17 one time, and that just gives you, you know, y. And then 51 divided by 17. Remember, 51 divided by 17. Remember how that sets that up? And I believe that's 3. And I could definitely use my calculator to double check that. 51 divided by 17 is 3. Okay. Because 17 times 3 is 51. So 51 minus 51 is 0. Yeah, so that means that y is equal to 3, or you can say 3 is equal to y. Okay. So notice here, you know, how what we did was we used the division principle. So we want to say that we use the division principle. So to undo times, you do division. So you divide both sides by 17. And you know, sometimes when students are learning, if they're wondering, well, how did she know not to? How come she didn't add 17, or how come she didn't subtract 17? If I had a term being added on to y, or a term being subtracted onto y, then you use the addition or subtraction property. So like here on x, you had a term being subtracted onto that, right? -6. And here you had an x and you had a term being added onto that. See, but here you don't see a plus or minus sign. So like you don't have this. Did you have this? 51 equals 17 plus y. See, you didn't have like 17 is being added on to y. You didn't have that. You also didn't have 51 equals, if I do negative 17 plus y, maybe something like that. I didn't hear the negative 17 minus 17 is being in the form of subtracted right onto the y minus 17 on top of that, or on top onto y. So these would require the addition subtraction property. Here you could add 17 to both sides. Here you would subtract 17 to both sides. So here you would subtract 17 on both sides. Whereas here you would add 17 on both sides. Okay, so here you're using the addition subtraction principles. That's different from number 9. See, there's no plus sign and there's no minus sign in between 17 and y. So that's times. So in math, you undo multiplication by division. Okay. So, but if you had something like this, you know, these fall out, additive inverses fall out, equals to y. And then you would solve these, okay? So here you want to this one's not a sign number, it's not a sign rule. If you have 51, you can give away 17. You just have to make this an 11, decrease that, make that a 4. So 7, 8, 9, 10, 11. Looks like you have 4 left over. 4 minus 1 is 3. And over here, you add the step 7 and 1 is 8, 5, 1 is 6, so that's 68. Okay. So number 9 was an example of showing you the division property. Now on number 10, this is the coefficient is 5 sevenths. 5 sevenths is a coefficient. So remember what I said earlier is when we have, I'm going to say use the multiplication principle when the coefficient, which is the 5 sevenths, is a fraction. Okay, so when you have a decimal coefficient or an integer coefficient, we can divide. So here's 17. This is a coefficient. Let me highlight that. It was 17 was it's not a decimal, but it's a, you know, an integer. We just divide by it. But when your coefficient, see the 5 sevenths is a fraction, 5 sevenths, it's a fraction. You want to use the multiplication principle, okay, when the coefficient is a fraction. So you want to multiply by its reciprocal. Multiply by its reciprocal. So in other words, they say loosely like flip. Let me see. So if I ask the question, what's the reciprocal of 5/7? You would say 7/5. Okay, so because we didn't say take the opposite. We didn't say take the opposite. So don't say -7/5, because then you're doing something extra. You're flipping it and taking the opposite. We didn't say to do that. We didn't say to flip it and take the opposite. We just said multiply by its reciprocal. So the reciprocal of 5 sevenths is 7/5. So I'm going to multiply both sides by 7/5. So if I look at this equation, I'm going to put 7/5 times 5 7x. So I'm multiplying both sides by 7/5. So I'll do the same thing over here. I have 65/1, imaginary 1, times 7/5. Okay. So I put 65/1 so that it can look alike, look like a fraction like this, okay? And the way we multiply fractions is straight across. 7 times 5 is 35. So this is 35/35x. And 35/35 x is just 1x, and 1x is just x. And that's what the computer's gonna want. That's what the computer's gonna want. Just x equals for 1x. Okay. So they don't want you to put that 1 there. They'll complain if you put 1x in your answer. They just want x equals 2. Okay. Okay. So then on this other side, if I multiply straight across also, 65 times 7, it's a large number, looks like 455. And 1 times 5 is 5. So when you divide 455 divided by 5, that gives you a 91. Okay. So the other thing I could say, like, these, divide diagonally into each other. 5 goes into 5 one time. And 7 goes into 7 one time. So those simplify also. And we just end up with 1x. Okay. Okay, so now let's go to, I think the ones that the math department. Yeah, now we're going to go to the ones that math department made. Look. It's these. All right, so it says solve a linear equation using equivalent equations to isolate the variable. Express your solution as either an integer or a fraction, a simplified fraction. So this has to be reduced or simplified, right? Or a decimal number. Usually we just leave decimals if the problem starts off with decimals or if the problem is an application. That's usually when we keep the decimals. Okay. So if you look at number 1, t minus 5 equals 9. Okay. So, what probably would be a good idea is if you were to pause the video and then work the problem on your own, and then start the video again to check your answer. Okay, that's probably going to be the best thing. And usually in a class time, that's what I'll do. In the class time, I'll give students a minute and I time it on my watch. I give them a minute and then I call out the answer and then I work it out. If they didn't get the answer, double check that. So I think you should do that, like pause the video and work either one at a time out or work them all out, or like the first 3 and then start the video again. Okay. Okay. So, I'm sorry. What happened? I'm sorry. What happened on number 1 is I did do an edit, and I'm sorry. I should have mentioned that edit. I did on purpose change the 9 to -9. So maybe you can, if you worked it out, maybe you can go back up here and work it again with it being -9, because I did edit that. And again, it's just so we can work with some different sign rules. That's the purpose for doing that. Because otherwise, if I don't, then we're probably not using any sign rules. So I want us to practice our sign rules. So here you want to isolate t. You want to move the -5. So the opposite of a -5 is a +5. And then you see that these cancel out, they zero out. A number plus its opposite, that just gives you t. And on this side, this is what they call rule number 2. You're adding 2 numbers with different signs. And you definitely want to subtract. So you can do 9 minus 5, which is 4. And you definitely want to keep the sign of the number that has a larger absolute value, which is 9. And you backtrack to its sign. See how I edit that? It's a negative to begin with because I edit that. So that would be a -4. And what we're doing is we're using the addition property. It's not the subtraction property, it's the addition property. You like added 5 to both sides. Okay. Okay, number 2, I also didn't edit. I changed this 14 to a -14. And I changed a subtraction to a +14. Okay. Okay. So here you want to solve for V, and the term I would move and use properties on would be the +14. 14, I would move the +14 as opposed to this one, because this is actually closer to V. This makes it farther away from V because you have it has to cross the equal sign. So this is closest to V. So I want to move that one. Opposite of a +14 is a takeaway 14. And you know these are called additive inverses. Okay. So yeah, equals to V. And then there's no harm in putting inserting little plus signs in between there. We've got -14 plus a -14. That gives you a negative 28. 4 and 4 is 8. 1 and 1 is 2. Negative 28. Or you could say V equals -28. Those are both correct. And I think, okay, what I also did was this is showing vertical work, showing your work up and down vertically, but you could also show your work horizontally, horizontal work. Okay, and I can show you that if I have -14 equals V plus 14. So if I show my work horizontally, I want to move the +14 and I want to do a -14. But the way I can show that -14 is this way horizontally, V plus 14 minus 14, say it horizontally, as opposed to up and down vertical. What I do to one side, I have to do the other side. So over here, I have the -14, and then I have to do another -14 somewhere, either in front or in the back of that. And then these fall out. These over here fall out. So I just have equals to V. And now this is subtraction of sign numbers. -14 minus 14. Those are sign number rules. That's a rule number 3. And I think when you do rule number 3, you want to rewrite it as an addition problem. -14 plus -14. And now that is rule number 1. You're adding 2 numbers with different signs, so that'll give you -28 feet. Okay. All right, so it's showing you work horizontally. Okay, now on 3, you have some fractions and you want to solve for W. So do you see you need to move the -5/2? -5, and I didn't edit this problem. I worked with it as is. But I'm gonna add 5/2 to both sides of the equation and these zero out. So W equals. And then just remember that whenever you're adding or subtracting fractions, you have to have a common denominator. So the nice thing is that this already has common denominators of 2. And so these fractions are going to stay the same, okay, because of that. So I combine the top numbers, that's 5 and 5, right, which is 10 over 2. And now I'm going to simplify. So 2 goes into 10 5 times, so 5 equals L. Let's see, 5 equals to W, right? 10 divided by 2 is 5. So I have 5 equals to W. Or you could say W equals 5. So you're simplifying 10 over 5, which is, I mean, 10 over 2. You're simplifying that. 10 divided by 2, which is 5 times 0 remainder. Okay. And we're using, again, here we're using the addition principle. On number 14, we were using the subtraction principle. We're using subtraction on both sides. What's next? Excuse me. Okay, let's see. 4, I did do an edit only on number 4 on this page. Double check. Yeah, only on number 4. Yeah, did I do an edit? So what I did on the 6 and 3/10, I made it a negative. Can you do that for me? The 6 and 3/10, make that a negative. And then go ahead and take a minute to solve that. So you can turn off the video or pause the video, solve it, and then when you're done, turn it back on. You can check your answer. Okay, class. So did you get a -1 6/10? A -1 6/10? So here you want to solve this for y. You want to move the -4 7/10. So opposite, it's a positive. This divides out, or I should say cancels out. It cancels out, zeros out. A number plus its opposite zeros out. We have x equals. And on this side, I would say you have row number 2. You're adding 2 numbers with different signs. So you want to definitely subtract. So you should do 6.3 take away 4.7. Not the other way around. Not this way. Not 4.7 minus 6.3. That's wrong. Okay. And then you have to borrow, make that a 13. Decrease that, make that a 7. Or don't decrease it, so make it a 5. You're decreasing it. So 7, 8, 9, 10, 11, 12, 13. So 6 left over here. And 5 minus 4 is 1. So 1.8 6. And it's just I made, you want to keep the sign of the number with a bigger absolute value, so that would be a 6.3. You make that larger. And the sign on 6 is a negative, so you're going to have a negative 1.6. Isn't it going to be a negative because you go back to what was its sign to begin with and see the sign to begin with was a negative. Negative 1 6/10. Okay. Okay, now if we look at 24, on 24 we get to combine like terms. And so in our equation, we get to combine like terms on either side of the equation. And you would theoretically you would want to do that before the addition and subtracting property. But I think you're going to find this is very short when you start doing opposites. Well, actually, you want to combine like terms first, right? So let's see. When I combine like terms on this side, 24z minus 23z, that's just 1z, which is just z. And 19 plus 21, if I add 19 and 21 up on the side here, you can use your calculator. 9 and 1 is 10. Some of you probably already did that and found it was to be 40. So that is 19 and 21. These are constants. These are variable terms. Variable terms. So 24z minus 23z is just 1z, z. 19 plus 21, 9 and 1 is 10. 1, 2, 3, 4. So you have 1z equals 40. So z equals 40. Okay, and then on 6, again, if we combine like terms, so we combine like terms, so like you can combine the 16n minus the 15n, right? 16 take away 15 is 1n plus 3 equals negative 18. And they're going to want you just to leave it as n, not 1n. And sour, let's see. So I have n plus 3 equals negative 18. So I combine like terms. Okay, and then now we're going to use the subtraction principle. Or property. So you want to use opposites, right, when you do that. So you're doing opposites. So you use subtraction property, you want to use opposites because you want to move the plus 3 away from the end, and the opposite of the plus 3 is a take away 3. So this is rule number 1 here. Adding two negative numbers is a negative result, right? Negative 18. And remember, so there's like a plus sign here. Plus negative 3 is a negative 21. So negative plus the negative is still equal to the negative. So just be careful with those rules. Okay. Let me see. Okay, so y'all can go to page 95. Solve the following linear equations. Okay, remember linear equation means that they have this format, right? This ax to the first power. You have that linear, that little exponent of 1, and it's something that's called linear. Solve the following linear equations using equivalent expressions to equations to isolate the variable. Express your answer as an integer or a simplified fraction or a decimal. Number round to 2 places. And again, we only use decimals if the problem started with decimals or if you had some kind of application story problem. Okay, so number 7, we have 6u equals 42. Okay, so in math, remember that we undo multiplication by division. Okay, so I want to say that we want to divide by the coefficient itself, which means you want to divide by 6. So sometimes the coefficient's on the left, sometimes the coefficient's on the right. Also notice how 6 is an integer. Okay, it's not, I wouldn't make it into a fraction. I would use it's an integer. If it's an integer or a decimal, then you want to use the division principle, and that's what we're using. We're using the division property. So I have here that I highlighted divide by the coefficient itself. I'm reminding you that the coefficient is the number in front of the variable. In case you're wondering what is a coefficient, it's the number in front of the variable. So 6 is the coefficient. And you want to divide by the coefficient itself, 6. 6 is an integer, so don't divide by the constant. The constant is a 42. So you do want to divide both sides, but you want to divide by 6. Don't divide by 42. Why? Because 42 is a constant. And the rule says, doesn't say divide by the constant, the rule says divide by the coefficient. So you want to divide by 6. Don't put 6u. Don't do 6u, you're dividing by 6. These fall out, cancel out, divide out. And then 42 divided by 6 should give you 7. 42 divided by 6 gives you 7. So you have u equals 7. So what we're doing is, what you don't want to do is don't use the addition property. Don't try and use the addition property. Don't try and use the subtraction property. So don't use the division property. Don't use the addition property. Don't use the subtraction property. What you're going to use is you're going to use the division property. Or principal. Okay. All right. Okay, so can everybody try 8? Pause the video and try 8. Okay, so on 8, I hope you got, let's see, I reduced it. After I reduced it, I got 2/3. I got a fraction, 2/3. Hope you got the same thing. So 8 is -6y equals -4. So -6 times y equals -4. So that means in math, remember, we undo multiplication by division. So you want to undo this multiplication to get it isolated. And so you're going to undo multiplication by division. So you're going to divide both sides by the coefficient itself. You're going to divide both sides by -6. So I'm going to write that down. Let's see. Divide by the coefficient -6. These divide out, these fall out. Okay, and now I'm gonna do, and now over here, remember a negative divided by negative is a positive. Negative divided by negative is a positive. So this gives you 4/6. And you're going to reduce by 2. Reduce by an even number 2. So and you should do this on your test. When you take your test and you reduce things, you should let your teacher know what you're reducing by. And reduce by 2. These are both even. 4 and 6 are both even numbers, so you're safe with 2 because these are even numbers. So 4 divided by 2 is 2 on top. And on the bottom, it's 6 divided by 2, which is, for example, 2/3. Okay, now on number 9, -7/5 y equals 4. Okay, so here we're going to use the multiplication principle. And we're going to multiply by its reciprocal. So it means you're going to flip the -7/5 to get 5/7. And it's still a negative, so negative. Yeah, you have to keep the negative, it's still negative. Didn't say to take opposite. Okay, so when I show that I'm gonna multiply by the reciprocal. So I'm gonna take my 5/7 here. And it's still negative. And then multiply by this side, -7 is y. Okay, then I'm gonna take the reciprocal of this is this. And oh, it's a 4, right? So to get negative. Oh, that should be fine. Times what is the other side? The other side is 4. 4/1. 4/1. Okay, and then this side, negative times negative is a positive 35/35y. And these will divide out. So that's just y equals. Here I have to multiply it straight across. -20/7. And that's improper. That's improper. If you want it to make it into a mixed number looks like this. You just, if you want to do that, you want to do long division. So, so I know, so I'm doing, I know it's a negative, so I right now I have negative right here, the fractional part, but 7 goes into 20 about 2 times, 14, 15, 16, 17, 6 left over. 0, pull it down. And how many 7's going to 60 without going over? And you can always use your multiplication chart and see what mine have. How many 7's going to 60 without going over? So it's right here about 8. Because 9 would be too big. See, 63. So it's about 8. It's 56 with 4 left over. Okay, and I think I could, if you leave it like that, remainder at 4, but they say they want a quotient like a decimal, so they give you a hint. You'll see a box there. They want you to, that means that you should probably be able to type that in. So, but here, this is 2. If I'm going to, okay, if I'm going to do a mixed number, okay, I think I'm changing into a decimal. If I want to do a mixed number, I would have stopped here, right? So 20 divided by 7. 7 goes out twice, that's 14. 15, 16, 17, 18, 19, 6 left over. So that it goes clockwise like this. So there's a 2 that you put in from the beginning. And then the remainder, this 6/7. And it's negative. It's negative. It's a mixed number. And I was talking, I think I was also going to do the decimal here. I started on the decimal. So here, you know, your remainder was 4. So if you want to keep going, you could add a 0 here and pull it down. And 7 times 5 is 35. So still have 5 left over. We can add another 0 and pull that down. So it looks like that'd be so far 40 minus 35 is 5, and bring down the 0. 7 times 7 is 49. One left over is 50 minus 49, one left over. Okay, let me see if I use my calculator to check that out. Let's see, because it looks like it looks like it's gonna keep going, not terminate. 20 divided, oops, 20 divided by 7. Yeah, 20.857. And so on and so on. Okay. So it was 50 minus 49 is 1. Then you bring down that 0. Okay. Continue that process. Okay, but this is good in here. Okay, so go ahead. Go ahead and can you work on number 10? Work on 10. I'm gonna get a drink of water real quick. To work on 10, okay? And then I'm gonna come back and show you how to do that. All right, class, I'm back. Okay, class, I'm back. Let's see. All right, let's look at number 10. So 10, 11, and 12. And then we have this extra sheet. And on the extra sheet, I did have 3 examples to show you that involve fractions, 3 equations that have fractions in them to practice fractions. Okay, so let's look at 10. 10 also has a few fractions here. 10, 5/4 u equals 1/8. Okay, so you want to solve for u, isolate u, get u by itself. So you need to work with that 5/4, and that is a fraction coefficient. What you should do is when you're doing that, you're using the multiplication principle. And you're gonna multiply both sides of the equation by its reciprocal. And the reciprocal of 5/4 is a 4/5. So in a little bit, you're going to see your teacher multiplying both sides of the equation by 4/5. Okay, so I start on this side, 4/5 times 5/4 u equals 1/8 times that 5 times that 4/5 multiplying by the reciprocal. 4/5. Okay. And then you want to multiply straight across. 4 times 5 is 20. 5 times 4 is 20. Respect to you. And 20 goes into 20 one time. 1u. And then that's just u equals. Okay. The other side, you multiply straight across. 1 times 4 is 4. 8 times 5 is 40. And then if I reduce that, you can reduce by 2, but you get there a little bit faster. You reduce by 4. 4 divided by 4 is 1. 40 divided by 4 is 10, right? And so you end up with u equals 1/10. Okay. And as a decimal, what is if one of the decimal 1 divided by 10 happens to be 0.1, 1/10. So the 0.1. So we're doing long division. And we did that 1 divided by 10. So I'm going to pick a note here that we had to multiply fractions. Straight across. Multiply fractions straight across. Okay. Okay, now you look at 11. I'm going to combine like terms. On either side of the equation. Okay, so on this side you have 9 minus 3. That's just 6. You don't need a fancy sign rule for that. You don't need to add the opposite. If you have 9, you can take away 3. That's just 6. And over here, this is row number 2, different signs, adding 2 numbers with different signs. So you want to do 6 take away 4, which is 2 with respect to W. And you want to keep the number sign that has a larger absolute value, bigger distance. 6 let's be positive here. So you have this, this 2W is going to be a positive. Okay. So now you have negative 4W plus 6W is 2W. Okay, then you're gonna divide, right? You're gonna divide by 2. So first you try to combine like terms, excuse me, on the left and on the right. Now you're trying to solve the equation, so we're asking you to divide by 2. And this, well, actually, you know, 2 divided by 2 is actually W. And actually, I take that back. 6 to, I won't say divide. I can show you a word for that because the work is kind of minimal here on this part. If you look at 9 minus 3 is 6, but then you do 6 divided by 2 is 3. And 12, I would say that you combine like terms 4x minus 8x. So you combine like variable terms. So this is 4x minus 8x. It's like adding the opposite. 4x plus minus 8x. That's row number 2. So see, I changed that subtraction to a plus sign, and see how I took the opposite of 8 and made it negative 8. Okay. Then I look at this now with fresh eyes, and that is back to row number 2. So you're subtracting 8 minus 4 is 4. And you want to keep the sign of the 8 that has the larger absolute value. It's bigger. So it's going to be negative. Negative 8x. Let's see, I'm sorry. So we were subtracting, we're trying to find row number 2. It was, gave us 4. Okay, so that's going to give us 2. 4x plus negative 8x is going to be a negative 4x, because a negative, because you keep the sign of the number with the bigger distance, that's bigger. Negative 8 is bigger than that. And then just a little bit nervousness, right? X, you want to keep the variable x, don't lose your variable x. And it's equal to negative 4. And then divide. This divides into each other, this divides into each other. So you have x equals 1. And that's peculiar, but that's the answer. So you combine like terms on number 12. And then And then here, remember, we undo times by division. I also hope so. Undo times by division. Hey, Kasu, cool. Go ahead and stop the video if you're still writing, and but I'm gonna do the last 3 problems on the next page. Okay, so let's start with this one. These are all solving equations. Okay, so let's say you had this 7/4 x minus 3/4 x plus 7/8 equals 3/2. So the first thing we do is combine like terms. So if I combine 7/4 x, take away 3/4 x, you already have a common denominator of 4. So 7 minus 3 is 4. So you have 4/4 x. Okay. And that just simplifies to give you 1x. On the other side, 7/8 minus 3/2, you have to find a common denominator. So, oh wait, that's an equal sign. We didn't take that off. Yeah, you cannot, they're on across the equal sign. You cannot combine those. All you can do is rewrite that. Yeah, so let's see. So we have this simplifies to 1x. That's nice. So we basically have x plus, see how that, excuse me, see how we simplified this side? Okay, combine like terms. Okay. And then now here, you want to move the 7/8 out of the way. And we subtract it. These fall out. X equals, okay, so whenever you add and subtract fractions, you have to find common denominators. So I'm going to do my list of multiples on the side. My denominators, I'm gonna put the bigger one first, 8, and then 2. And I'm gonna put LCM equals LCD. Okay, 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8, 16, 24, 32. $40. Dot, dot. Okay, now let's try 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3, 6, 8, 10. Excuse me, a 12. And the first time you see a match should be at 8, right? Okay, I see. Looks like it should have been 16 here. 8 times 2 is 16. 8, 16, 24. 8, 16, 24, 32. And you see a match, I think. Is 8 the first match you see? Sorry. Okay, so sorry. So it's 8. Putting the sleep here, sorry. 8. Okay, so I'm gonna multiply these are called building up the fractions. I'm gonna build up the fractions. And so if I look at 2, I have count 1, 2, 3, 4 of them. So these are gonna be little 4s because on the bottom 2 times 4 is 8, and that's what you're trying to arrive at. So I just count 1, 2, 3, 4, and then 3 times 4 is 12. Okay, then we're taking away 7 eighths. So if I look at, I just needed 1 8. So this will be just times ones. Okay, so now I have common denominator, see 12 and 8. And now I can do 12 minus 7. See, 12 minus 7. So 7, 8, 9, 10, 11, 12. So it's just my fingers, 5 over 8. Okay, let's look at another problem. Let's look at this one. Negative 5 sevenths plus y equals negative 3 fourths. Let's see if I got that written down right. So negative 5 sevenths plus y equals negative 3 fourths. Yeah, this shouldn't be here. Sorry. Let me double check. Yes, that's correct now. All right, so you want to solve this for y right there. And this is kind of in the way of that. Okay, so we're gonna move this, and we can do adding opposites. This term is being added on to y. So I'm gonna use opposites of plus. I mean opposite minus is a positive. So y equals. Okay, so now we have negative 3 fourths plus 5 sevenths, okay? Okay. So we're gonna build up the fraction. I'm gonna look at multiples of 7 and 4. 7, 14, 21, 28. On 4, so 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16, and so on and so on. But I think we have a match at 8. Let's see, 4, 8, 12, 16, 7, 14, 21, 28. Okay, so far no match. 7, 14, 21, 28. So I think it's supposed to be 28. 4, 8, 12, 16, 20, 24, 28. Okay, build up your fractions. Okay, so so on the 4 here, how many multiples of 4 do we need? Let's see, 1, 2, 3, 4, 5, 6, 7. Looks like we need 7 for that. And then the liver uses a 7. 1, 2, 3, 4. And sorry, these don't go here. We're multiplying across. 7 times 4 is 28. And negative 3 times 7 is negative 21. And the other fraction is on the 7th to multiply by 1, 2, 3, 4. 7 times 4 is 28. Okay. That gives me 20 over 20, 20 over 28. And then you have negative 21 over 28 plus 20 over 28. That's going to be a negative. You're going to subtract 21 minus 20. It goes clockwise. Or you work with negative 21 plus 20. Negative 21 plus 20 is a negative 1 over the denominator, which is 28. Sorry, dozing off again. Sorry. So let's see. Are you okay with those fractions that I got? Negative 21 plus 20 is a negative 1 over 28. Okay. Yeah. And the yellow, you remember I taught how to do this on the calculator to double check that 3/4 is it's a negative. So put negative is down here, sign changer, -3. Then use this key here, this key right here. It's above this sine, cosine, tangent. They use these in trig. It's above the sine tangent and in between the bases and the pi natural log. So n over 10. But for us, it's -3, then press that button, and then 4, and then plus, and then 5, then hit that button, then 7 equals -1 over 20. That's what I have here. So you can check your work, but then your teacher, this is a test. So I'm going to be looking for, this is called building up the fractions. This is called finding the least common denominator, which is also the least common multiple, right? Synonyms. So you have to show your work for that, which was 28. Okay. Okay, one last problem. Negative 27/36, take away 3/4 equals 5/18, take away m. Let's say you have something like that. Okay, so one thing you notice is this can be reduced, this fraction. That would help a little bit to reduce that. And I think 9 will go into those. So if I rewrite that and make that a 9, negative 27 divided by 9, looks like that's a -3. If I show you that, negative 27 divided by 9, the -3. And 36 divided by 9, it's a 4. Okay, so let's see. So I'm reducing that, and that gave me -3/4. I'm just copying everything else down. Okay. And then these are like terms. So I can combine those like terms, and that'd be plus negative, be the best way to work that out. -3/4 plus a -3/4 equals 5/18 minus m. Okay, so like terms, I change the subtraction to addition because these are sign numbers. See, that's a sign number. Change it to addition, and then take the opposite. That's what I'm doing right here. And then this is rule number 1. Negative plus a negative is a negative. So 3 and 3 is 6, -6, -6/4 equals 5/18 minus m. And you reduce that by 2 right here. Reduce that by 2. So that gives you -3 halves. And then let's see, on this side, I reduced that to -3 halves, but then I have 5/18 minus m. Okay, so now, sorry, I'm dozing off again, sorry. I'm going to solve for m. I'm going to get m by itself. So I would move the 5/18 over to get m by itself. So do -5/18, -5/18. These fall out. And you have equals to -m. And then this side, you need to find a common denominator. So I'll do that work on this side over here. 18, 2 is even. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on and so on. Okay. 18 is 18 times 1 is 18. And I think right there you see that the match for that is 18. LCD equals LCM is 18. Okay. So this is already, when you build up the fraction, this already has 18 already in the denominator. So that one's good, stays. But this one you can multiply times 9. Like 2 times what, right, is 18. So 2 times 9 is 18. Okay. And then -3 times 9 is -27. And let's see, I'm running out of room to write that. So we should put it right here. So -9 times 3 is -27. Two times 9 is 18. And then these are times 1 because there was 18 steps on before. There's 18. It was already, you already had 18, so 18 times 1 is 18. Okay. And so this is -5 over 18, right? -27, and then you have that -5. So remember, I said there's like the little plus sign there, right? Okay. And let me just double check that. Let's see. It looks good. I think that's fine. So -27 plus a -5 is 27, 28, 29, 30, 31, 32, 27, 28, 29, 30, 31, 32. So it looks like we have a -32 over 18. Okay. I think that's fine. And then notice how you have a coefficient. And actually what I can do is I can reduce this. I shouldn't say it's a coefficient because it's a constant never by itself. But if I reduce that by 2, -32 divided by 2, half of that, it's a -16. And then half of 18, it's 9. So you have -16 nines equals -m. And then you're almost done. It's just that in math, they don't want this to be a negative. They want 1m or positive m understood, but they don't want a negative number, a negative value. So you have to take it one step further. And really what happens is you just flip these signs. I mean, you're dividing by -1. This is like a -1m. So what you're doing is you're dividing this by -1 and also this by -1, which makes it a complex fraction. This cancels out. So you have m equals, and this is a complex fraction, but negative divided by negative is a positive. So anything divided by 1 is itself. And so that gives you negative divided by negative is a positive, so that should give you a positive 69s. So negative 69s divided by negative 1 is a positive 69s. And then 69s can be made into a mixed number. If you do, you have to do long division. So that will go into it one time. So I don't know where to show that. 16 divided by 9 one time. 9 times 1 is 9. 10, 11, 12, 13, 14, 15, 16. Looks like there's 7 remainder. So it looks like that would be m would equal, goes clockwise, right? And it is positive. So it looks like it's going to be 1 and 7 nines. M is equal to 1 and 7 nines. Okay, so I was just double checking that. So we got 16 over 9s, 1, 7 9s. For the middle, negative 1 over 28. And then the very first one was 5 8. Okay, so we got the other one. I'm not sure about essay type. With that surveying, so that's the one I'm sure about. Okay, so I was just double checking the other answers to make sure I got those right. So yeah, 5 8s, negative 1 and 28, and 1 and 7 nines, or 16 nines. Okay. All right. So sorry, class. I think I was dozing off again. So sorry about that, but I know I double checked. That's why I double checked to make sure I did those right. And I did. Okay, double checking that. So I hope that helps. Okay. Take care.